Look up at the moon tonight. It doesn't matter where you are on Earth. It doesn't matter if it's tonight, next week, or 10 years from now. You will always see the same face, the same craters, the same dark patches, the same familiar shape staring back at us. So here's the big question. Why do we always see the same side of the moon? Is the moon following us? Is it stuck? Or is something much stranger happening? Let's uncover the real reason, because it's one of the coolest space coincidences ever. First, the moon does spin. Let's clear up a huge myth. The moon is not frozen in place. It actually spins on its own axis, just like Earth does. But here's the twist. The moon spins at exactly the same speed that it orbits Earth. One rotation, one orbit, perfectly matched. This strange cosmic dance is called tidal locking. A simple way to understand it. Hold your phone in front of your face. Now slowly walk in a circle around a chair, but keep your phone facing the chair the whole time. You are rotating, but the chair only sees one side of your phone. That's exactly what the moon is doing to Earth. The moon takes about 27 days to orbit Earth, and it takes about 27 days to rotate once. Because those two times are the same, we only see one side. But why did this happen? This didn't start out this way. Long ago, billions of years ago, the moon was spinning much faster. Earth's gravity slowly changed that. Here's how. Earth's gravity pulls harder on the side of the moon closest to us. That uneven pull creates tidal forces. Over millions of years, those forces acted like a brake, slowing the moon's rotation down. Eventually, the moon reached a stable position, one side always facing Earth. That's tidal locking. Earth does this too. Here's something wild. The moon is also slowly affecting Earth. The moon's gravity causes our ocean tides, but it also slightly slows Earth's rotation, very slowly, like milliseconds per century. In the far, far future, Earth could become tidally locked to the moon, meaning one side of Earth would always face the moon. Luckily, that's billions of years away. What about the dark side of the moon? You've probably heard the phrase, the dark side of the moon, but that's actually wrong. The far side of the moon is not always dark. It gets just as much sunlight as the side we see. It's just the far side, the side facing away from Earth. Astronauts have been there, satellites have mapped it, and it looks very different. More craters, thicker crust, fewer dark lava plains. Still mysterious, just not dark. Why other moons do the same thing? The moon isn't special in this way. Most large moons in the solar system are tidally locked. Jupiter's moons, Saturn's moons, even Pluto and its moon Charon are locked to each other. Tidal locking is common. It's what gravity does when it has enough time. Can we ever see the other side naturally? Almost. Because the moon's orbit isn't perfectly smooth, we get a tiny wobble called libration. This lets us peek at about 59% of the moon over time. But the full far side, only spacecraft can see it. Why this matters? This simple fact, seeing the same side of the moon, tells us something powerful. It shows how gravity shapes the universe, how time changes motion, how even massive objects eventually settle into balance. The moon isn't chasing Earth. It's not stuck. It's locked in a perfectly timed cosmic dance. Final thought. For thousands of years, humans stared at the moon and thought it was mysterious. Today, we know the science. But somehow, it's still just as magical. And the next time you look up and see that familiar face, remember you're witnessing gravity, time, and motion working together. If you enjoy questions like this, subscribe to Cosmos Why, because the universe always has another mystery waiting.